Now this is paper E on the Solomon C3. Please pause and have a go. Look at question 1. It says state the range of f. And we're given that f is that. So it's the modulus of 2x minus 5. What are the possible y values? So this is very straightforward. So we look at the possible y values and the possible x values, and it's what sometimes it could be helpful. I mean, this is easy, but let me just remind you that the range means what are the possible y values. If I draw a graph, I know that the graph is not this graph where it cuts the x-axis at minus 5. So imagine I had the graph of 2x minus 5. I want the modulus of that. So basically, it's all the parts that's negative, which starts from here, is reflected, and this part is simply deleted. I don't want this part. So this, if you like, is the graph of f, okay? Where the gradient should be a bit steeper, really, shouldn't it? The gradient is 2, so it should be a bit steeper. And that will sort of do. And I know that it cuts the coordinate axes at when y is 0, it's 5 over 2. Is that right? 5 over 2. And this is 5. And we can see that the y values are all positive because it's a mod graph. That's fairly obvious anyway. So we can say that f of x is greater than or equal to 0 for 1 mark. So part B, it says evaluate f g of minus 2. So let's work out g of minus 2 first of all. G of minus 2 is, I substitute x equals minus 2 into there, and I get the natural log of 1, which we know is 0. So therefore, f of g of minus 2 is just f of 0. And f of 0 is equal to the modulus of minus 5, which equals to 5. So for 2 easy marks, we're just substituting in x is equal to minus 2 in the function g, finding that value and then substituting that into the f function. Very good. So f g of x, f of g of x, let me just do this a bit neater. F g of x is equal to 3. What does that mean? It means that modulus of 2 bracket, where I see x, I put the function g, yeah, f of g of x. So it's modulus of 2 bracket the natural log of x plus 3 minus 5 is equal to 3. So like all modulus equations, if I remove the bracket, remove the modulus, I can either have positive 3 or negative 3. Okay, so in other words, if the modulus of something equals to 3, then either this is equal to 3, or I could have this is equal to minus 3. Yeah, because if I have, supposing that was equal to minus 3, what happens when I mod it? It becomes 3. Okay, so it's very important to know that when I have the modulus of something equals to 3, then whatever that something is, it can either be 3, obviously, or it could be minus 3. So let's just solve the equation where, so that's how you algebraically get rid of your modulus. Okay, so here I could remove it and I have 2 times the natural log of, I've got an additional bracket here, haven't I? X plus 3 is equal to, taking the 5 over, it's 8. Okay, I've just taken the positive log. So natural log of x plus 3 is equal to 6. Now in order to get 4, not 6, because I'm dividing, not subtracting, deliberate mistake. Well done. Now, in order to get rid of the natural log, I can take the exponential function, yeah? E both sides, because log means natural log is just log base e. In other words, I just e both sides, okay? So x plus 3 is equal to e to the 4, and therefore x is equal to e to the 4 minus 3. Okay, so that's one solution. Okay, so for our other solution, we do the same thing. The green part is now equal to minus 3. Okay, so the green part, which, let me just do this solution in red. So it's 2 times natural log of x plus 3 minus 5 is equal to minus 3. Rearranging that, I get the natural log of x plus 3 is equal to 1, and therefore x is equal to e to the power of 1 minus 3. So x is equal to e minus 3. So I did that quite quickly. Okay, now for the next part, supposing we have to show that f of x equals g of x has a root alpha in the interval 3, 4. Okay, what we do is we say f of x equals g of x. That's what we're trying to solve. That implies that f of x minus g of x has to equal to 0. And that's the key line right there. Okay, so if I write that down, I know that if a root, when I'm finding a root equals to 0, if it's in that interval, then there must be a change of sign. So that's the key right there. So this line here is very important. F of x equals g of x implies that f of x minus g of x equals 0. And now I can use the change of sign property. Okay, if I have an equation with a root where it equals 0, then I know to find that root, I just have to show that there's a change of sign between the interval 3 and 4. So let's just do that. Now, I don't really need to do this, but I could even go one further and say let h of x equals f of x minus g of x. Okay, and therefore I can use my function notation, okay, and show that h of 3, if I work out h of 3 by substituting in x equals to 3 into this equation and this equation and subtracting them. Let's see what and if we tap that into a calculator, we minus 0.79. So now I can do h of 4. Again, substituting in x is equal to 4 into both parts and subtracting. Okay, so I put x is equal to 4 into that one and subtracting. What I get is, so h of 4, putting it all into a calculator, I get 1.1. And from here you can see that there's a change of sign, and therefore the root, or here the solution has a root in the interval 3, 4. Here is a little bit of technique for you to do these types of questions. X naught is equal to 3. So what I could do is actually to put 3 and press equal. And now if I delete that, I can see that my answer button is 3. Okay, so that's my x naught. And now to find x1, I write down exactly as I see it. So it's a half times 5 plus natural log of xn, which is my answer button, plus 3, close brackets. And now each subsequent press of the equal button will give me the next iteration. So my first iteration, x1, is therefore equal to 3.40. So let me just write that in. X1 is equal to, now to 4 significant figures, it's 3.396. X2, rather than having to write everything out again, I simply need to press equal. Which is 3.428. So 4 significant figures. And I want all the way up to x4. So again, if I press equal, x3 is equal to 3.430. And finally, x4 is 3.431. In order to show that x4 is the solution, what we do is to show that to 4 significant figures. So let me just highlight, that is the 4th significant figure. Now, that is, what is the upper and lower bound of 3.431 to 4 significant figures? Well, remember that this is the 3rd decimal place, okay? And I go half a unit above and half a unit below. So let me just, now this is quite tricky, but the upper bound is actually easier to see. Upper bound is equal to 3.4315. The lower bound, 3.4295. I have to be very careful here, which is the obvious mistake. And so it's actually 305, okay, because we take away this number away from the rest, so it's half a unit above and below, okay, so it's this. And from here, what you should do is now again plug it into h of x. So I said h of x is equal to that, and I should get a change of sign. Okay, so let's do that. H of, let's say, start of the lower bound, 3.4305, and I tap that into my calculator. And this, if we work it out on a calculator, is minus 0.000052. And h of the upper, so this is the lower bound, isn't it? This is the upper bound. Now we do it the upper bound, which is 3.4315, and that is equal to 0.0018. And since there's a change of sign, and we can say that h is continuous, therefore alpha equals to 3.3431, correct for significant figures. So the key, again, I'll remind you, is to show that a given number is correct, you have to use the upper and lower bound of that number. So let me just circle this. The upper and lower bound is the key, okay? Show that there's a change of sign in the upper and lower bound.